So we mentioned exoplanets. What about Earth-like, or I don't know what the right distinction is. If is it habitable or is it Earth-like planets? But what are those different categories, and how can we tell the difference and detect each?
Right, right. So we're not at Earth-like planets yet. All the planets we're finding are so different from what we have in our solar system. They're just easier planets to find. But like,
In which way?
for example, there could be a Jupiter-sized planet where an Earth should be. We find planets that are the same size as Earth, but are orbiting way closer to their star than Mercury is to our sun. And
So
they're so close that because close to a star means they also orbit faster. And some of these hot super Earths, we call them, their time to go around their star is less than a day. And they're heated
super
so much
Earth.
by their star. They're heated so much by the star, we think the surface is hot enough to melt rock. So instead of running out by the bay or the river, you'll have like liquid lava. There'll be liquid lava lakes on these planets, we think.
And life can't survive.
Way too hot. The molecules for life would just be molecules needed for life just wouldn't be able to survive those temperatures. We have some other planets. One of the most mysterious things out there, factoid, if you will, is that the most common type of planet we know about so far is a planet that's in between Earth and Neptune size. It's 2 to 3 times the size of Earth. And we have no solar system counterpart of that planet. That is like going outside to the forest and finding some kind of creature or animal that just no one has ever seen before, and then discovering that is the most common thing out there. And so we're not even sure what they are. We have a lot of thoughts as to the different types of planet it could be, but people don't really know.
I mean, what are your thoughts about what it could be?
Well, one thought, and this is more when we want to be rather than might be, is that these so-called mini Neptunes, we call them, that they are water worlds, that they could be scaled up versions of Jupiter's icy moons, such that they are planets that are made of more than half of water by mass.
So, yeah, and what's the connection between water and life and the possibility of seeing that from a gas perspective?
Okay, so all life on Earth needs liquid water. And so there's been this idea in astronomy or astrobiology for a long time called follow the water, find water. That will give you a chance of finding life. But we could still zoom out, and the community consensus is that we need some kind of liquid for life to originate and to survive, because molecules have to react. If you don't have a way that molecules can interact with each other, you can't really make anything. And so when we think of all the liquids out there, water is the most abundant liquid in terms of planetary materials. There really aren't that many liquids. Like I mentioned, liquid rock, way too hot for life. Mm-hmm. We have some really cold liquids, like almost gasoline, like ethane and methane lakes that have been found on one of Saturn's moons, Titan. That's so cold, though. And for exoplanets, we can't study really cold planets because they're just simply too dark and too cold. So we usually are just left with looking for planets with liquid water. And to your point, you remember we talked about how planets are less than a pixel in that way to say. So we can't see oceans on a planet. We're not going to see continents and oceans, not yet anyway. But we can see gases in the atmosphere. And if it's a small rocky planet, and this is going into some more detail, if we see a small rocky planet with water vapor in the atmosphere, we're pretty sure that means there has to be a liquid water reservoir. Because it's not intuitive in any way, but water is broken up by ultraviolet radiation from the star or from the sun. And on most planets, when water is broken up into H and O, the hydrogen, will escape to space. Because just like when you think of a child letting go of a helium-filled balloon, it floats upwards. And hydrogen's a light gas and will leave from the planet. So ultimately, if you have water, unless there's an ocean, like a way to keep replenishing water vapor in the atmosphere, that water vapor should be destroyed by ultraviolet radiation.
Got it. So there's a need for a liquid. I mean, I guess is water. Well, is water essential, or is it other liquids? I mean, the chemistry here is probably super complicated.
Well, there's not an infinite number of liquids.
Right.
There's maybe like 5 liquids that can exist inside or on the surface of a planet. And water is the one that exists for the largest range of temperatures and pressures. And it's also the easiest type of planet for us to find and study is one with water vapor, rather than a cold planet that has ethane and methane lakes.
What's your personal in terms of solar systems and planets that you're most hopeful about in terms of our closest neighbors, that you kind of have a sense that there might be somebody living over there, whether it's bacteria or somebody that looks like us?
I'm hopeful that every star
Every
nearby
star
has a planet,
has some life.
because it almost has to for us to make progress. We have to have that dream condition.
So the dream condition is like life is just super abundant out there.
Yeah, the dream. Well, yes, the dream condition
And
is that life is super abundant, and it's based on the thought that if there is a planet with water and continents, that it also has the ingredients for life, and that the kind of the base kernel thought is that if the ingredients for life is there, life will form.
life will
That's
form
what we're holding on to.
with a relatively high probability.
Yes, that's it.